Okay. Can everybody hear me? Any questions before we start? Can anyone remember what this module is about? So today we're going to talk about coursework 1. So coursework 1, as I'm sure you've all seen, is available on Moodle for you to start. And this lecture is all about coursework 1, and it's a central component. It's probably the most important lecture about coursework 1. And it's how to read research papers, scientific research papers. Has anybody noticed, has anybody tried to read a research paper yet? Has anybody tried? 1, 2, 3, 4? Okay, good. That's good. So if you've tried to read a research paper before, then this lecture will be nice for you. It will be nicer. Has anybody noticed that it's not easy? Anybody notice that? It's difficult. It's difficult to read a research paper. Has anybody noticed it can be time consuming? Anything else that makes it difficult to read a research paper? Another thing?
Bringing different resources from different research papers and making it comprehensible.
To make it comprehensible, how to understand it.
How to understand it and how to analyze it and make it clear for someone else to read what you're doing.
Yes, that's exactly what we're going to be talking about today. Well done. Well done. So research papers, they're complicated, they're hard to understand, and they're very dense. They're dense with a lot of information. And then you're looking at it and you see that there's complexity, density, lots of information, and you're like, what am I supposed to take away from this? What am I supposed to be looking for? What am I supposed to learn? What am I supposed to take away from this? Because you can't take away everything. Right? You can't memorize the paper and learn everything that's there. So in some ways, this is very similar to the minutes of meeting protocol. Does anybody remember the minutes of meeting protocol?
Yeah.
So at the end of the meeting, you're asking yourself, what am I supposed to take away from this meeting? I just went through a meeting. Like, what is the takeaway? And that's in the to-do list, right? You have a to-do list. Well, it's kind of similar here. You're looking at a research paper, and then you're trying to come up with a list of takeaways. Like, what am I supposed to take away from this? There's so much information and so much complexity here, and that's what we're talking about today. What are we looking for when we read a research paper? What's the takeaway? And we call it extracting the essentials. What is the essential information that I need to look for and focus on when I read a research paper? Because not all information is of the same importance. That's the basic principle behind this. Different information has different levels of importance, and that's one of the messages here. So why is this an important skill? It's because most projects start with a literature review. Why do most projects start with a literature review? Because you want to find out what has been done before on a given topic. What have people worked on previously? But a research paper, you're faced with a challenge. You're essentially faced with an information deluge. You have a tidal wave of information crashing down on you. And you don't want to die. So this is like a survival mechanism. This is a kind of survival mechanism to make it as dramatic as possible. A single paper can be very complicated, right? Detailed, it can offer a detailed mathematical framework, a complex algorithm, complex data analysis techniques. Each individual research paper is usually the result of a team of people working for multiple years on it. So you get the final result. But that is usually a project that's been going on for multiple man-years, maybe 5 to 10 man-years, all summarized in 10 pages. So there's a lot of work. Another challenge is there is a very large volume of previous literature. There are millions of previously published papers. And keeping up with this literature explosion is identified as one of the top challenges for any field. It doesn't really matter what you're doing. Keeping up with the literature is one of the top challenges for any researcher. So the question is, how can we navigate through this massive complexity? That's what we're trying to do today. We're trying to teach you a new skill. It's a brand new skill. You've never seen it before. You've never heard of it before. This is the first time you're ever going to see or hear about this skill, about how to read research papers. It's a very unique skill. It's a very valuable skill. And it's a skill you can use for the rest of your life. It doesn't matter who you are or where you are, what business you're in. The ability to read research papers and extract the essentials is really, really a valuable skill. It doesn't really matter what you're studying or what problem you're working on. If you have this skill, you are head and shoulders above the rest of the populace in terms of your knowledge and understanding of the world. So just a little overview. So we're introducing and motivating why this is an important topic. There is actually a little bit of related work on this topic. We're not going to go into deep depth about that. We're going to discuss concept versus implementation. These are two magic words. And if you can understand the difference between concept and implementation, your life is going to improve dramatically from this point on, if you can understand this. It's not very difficult to understand, but it's very important, and a lot of people do not understand the difference. They don't know what the difference between these two things are. Once we know what concept versus implementation means, we understand this, we're going to extract the essentials of some computer science research papers. We're going to extract the concept. Look, there's the concept. The implementation, there it is. They're two separate things. The essential related work, the essential input data characteristics, and the essential evaluation technique that's used in the paper. Those are the essential elements of a research paper. And then the question is, how do we extract those essential elements? And we're going to look at some examples. And hopefully we'll have time to discuss this breadth versus depth topic. Does it sound exciting? Yeah. It's surprising that this skill set even exists in the first place. You probably didn't know that this skill set even existed at all. But it is a skill set, and it's only taught in this module. It's not taught anywhere else in the world, actually. It's only taught in this module, which is also exciting. So the idea is, if we look at a research paper, and it doesn't matter, it's not just a research paper, if we look at the world, we read anything, not all details are essential. If we look at the world as a canvas of information, the information does not have equal importance. So not all the details are essential, nor are they possible, by the way, to obtain when getting an overview of the previously published literature. You don't need all the details. And then the question is, well, what do you need, right? So keep in mind, when we're talking about this skill, we have some goals in mind. What is our overarching goal? Our goal is to learn the skill set that we need for a literature review. So this is all preparation for a literature review. It's a special skill that we use and develop for conducting literature reviews. Because when you conduct literature reviews, you're confronted with millions of research papers. And you need something, you need a lens, you need a tool to navigate this mass of crazy information. I remember when I was a master's student, actually, and I had friends that were studying for their PhD, and one of my friends had a stack, he printed them out back then, he had a stack of research papers like this big on his desk, literally a stack, 1,000 pages or thousands of pages. And I just looked at it and I thought, how is anybody supposed to manage that? How are you supposed to manage that level of information? That's impossible. Like, that seems impossible. It's not impossible, actually. That's what we're learning today. It's possible to extract the essentials from each one of those papers. So why did he have a stack of literature on his desk? It's because he was doing a literature review. He was trying to find all the previously published solutions related to the work he was looking at. So a literature survey is a good way to obtain an overview of the literature, find the solved problems, and when you find the solved problems, you implicitly find the unsolved problems. So you can only discover the unsolved problems if you've got some knowledge of the solved problems. So what we're talking about here is based on previous experience of reading and writing surveys and supervising students. If there are questions or comments, feel free to interrupt me anytime. So first major hurdle is trying to understand the difference between concept and implementation. This is a key element in your skill set. If you can understand the difference between concept and implementation, you're already halfway there. So if we look up, everybody knows I like to do this, I like to look up the dictionary meanings of words and see if they're helpful. If we look up the word concept in the dictionary, we get these definitions. One is a general notion or idea, a conception. Another one is an idea of something formed by mentally combining all its characteristics or particulars, a construct. A directly conceived or intuited object of thought. That's a pretty cool definition. They're abstract, aren't they? Those are abstract definitions. Now we're going to look up the definition of implementation. The act of accomplishing some aim or executing some order. The act of implementing, providing a practical means for accomplishing something, carrying into effect. Now, those definitions are difficult to understand. So I'm going to try to explain them using my own language. A concept is an idea in your head. That could be the definition of a concept. An idea in your head or in somebody's head. It doesn't have to be in your head. It could be in anybody's head, wrapped inside your skull. The skin in here. That's a concept. The implementation is the realization in physical reality of a concept. So you take the idea and you provide a physicalization of that idea. Or you could call it an implementation, but the realization of an idea in real life in physical space. So it comes out of the head and it gets transformed into reality. That's the difference between concept and implementation. Is that understandable? Hopefully. It's not that difficult to understand. It's not mind-blowing or anything. So again, using my own words, concept is an idea or a thought. A concept is abstract, not something not something with mass that can be weighed on a scale. So it's abstract. It doesn't necessarily exist in reality, or it's not physical. There's no physical idea. It's abstract. It has no mass. I'm trying to make it clear. I don't know if that actually helps, that explanation. Concept is very abstract. In fact, it's difficult to define exactly what a concept is. We don't want to belabor this point too long. We could have like a philosophical debate for several days trying to nail down the exact definition of concept. It's a philosophical idea. But we're not going to do that in this class. We're just going to say it's an idea or thought in someone's head. And it has no mass, it has no physicalization, no external reality. An implementation is an actualization or a realization of a concept or idea. It's a concept or idea that has been brought into reality. It's not just imagined anymore. The concept is imaginary. An implementation is not imaginary anymore. It exists in reality. It can be measured, it can be studied, it can be weighed, it can be evaluated. That's an implementation. Is everybody starting to see the difference between concept and implementation? Of course, we're going to keep going over this theme. It's going to be recurring over and over again for the rest of the module, actually, because coursework 1 is a summary of 1 research paper, but coursework 2 is a summary. Coursework 3 is a summary of 10 research papers, and you're going to be asked to extract the concept and implementation from each one of those papers. A concept usually starts out as an idea in someone's mind. This is the transformation from concept into implementation. A concept is then often written down on paper, perhaps as a hypothesis or a specification. And then a concept is implemented. So you can think of it in natural language as, I have an idea as the concept, and how are you going to do it as the implementation of that idea in natural language. So I have a concept. I could have a concept like, I have the idea in my head to increase class attendance. That's a concept. I want to increase class attendance. And then the question is, well, how are you going to do that? The question should be reformulated as, How are you going to implement this idea? Right? And there are many different solutions, or there are many different implementations for a given concept. How are you going to increase class attendance? One implementation could be, I will execute every student that doesn't attend class. Actually, that's not going to work, right? Because that's not going to get them. If they're dead, they can't go to class. That's one implementation. It's not a very good one. Another implementation could be, oh, I will give bonus points on the courseworks for everybody who attends class. That's an implementation of the idea, right? And that would work. That would increase the class attendance, right? I will offer an Amazon voucher for everybody that attends class. That's an implementation of an idea. That would be very effective. Or I will offer a new iPhone to everybody that attends class. That would really work. That's an expensive implementation, very expensive one. Here's another very boring example, a writing utensil. A writing utensil is a concept. It starts out as a concept. What kind of a concept? A tool that can be used to communicate with others using symbols drawn by a person or animal. There are some animals that can write, by the way. So that's a concept. Writing utensil is a concept. And there's the concept in somebody's mind. An implementation of a writing utensil is a pencil. Right? A pencil is a writing utensil. Well, another way to formulate that is a pencil is the implementation of a writing utensil. A pencil is a type of writing utensil, or more specifically, it is the implementation of a writing utensil. With a pencil, graphite is used to write down on a piece of paper. That's the implementation of a writing utensil. So we're trying to talk about the difference between concept and implementation. Carrying on with this theme, for any given concept, there are an infinite number of implementations. So there's a one-to-many mapping between idea and implementation. Writing utensil has an infinite number of different implementations. If we all take out the pen and pencils in our pockets and our backpacks, every single one of them is going to be different, slightly different. Every implementation is going to be a little bit different. We have lots of different writing utensils: pens, markers, Palm Pilots. Well, Palm Pilots, do those still exist, actually? Does anybody know what a Palm Pilot is? Nobody knows what that is, yeah. Anyways, that was an implementation that has come and gone out of existence. I guess they don't exist anymore. An unlimited variety of different implementations have been offered for a writing utensil. How many different pens and pencils have you seen in your lifetime? Right, unlimited number. So for a given concept, there may be many different implementations, and this is an essential element when reading or writing research papers, as well as in most other areas of life that require critical thinking. So if you need to think critically about anything, you have to make the distinction between concept and implementation. If you want to understand the world at all and think about the world at all and make sense of the world. But we're especially focusing on research papers. So as you might have guessed, from each research paper, you have to extract the concept and make that distinct from the implementation of the concept. So if we're looking at a scientific research paper, the first question we have to ask ourselves is, what is the concept behind this paper? What is the idea? What are the authors trying to achieve with this research paper? Does anybody know? There's a generic answer to this question. When you publish a research paper, you read a research paper, what are the authors trying to achieve? What is the goal of publishing a research paper? Anybody want to try to answer that? Why do we publish research papers? Answer?
A, to just share what you have discovered and what you have found. B, to allow a community of contributions, that is reproducibility.
That's right. To contribute to knowledge, to expand our knowledge. In other words, to report something new. That's what a research paper is for, to report something new. Like you have made, what this student said is you've made a discovery. What's your name, by the way?
Akshita.
Akshita?
Yeah.
Is that Indian?
Yeah.
That's a tricky one. I might have to ask you that several hundred more times.
That's okay.
Akshita said to report a discovery, and that's correct. Good job, by the way. It's just to report some new knowledge, like, hey, we've done something new, and we'd like to tell you about it. We've expanded the base of knowledge. We've expanded our understanding of artificial intelligence or visualization. We have done something new. We've done something new that hasn't been done yet, and we're here to tell you about it. So the concept is, this is the concept. When you're reading a research paper, what is the goal of the work? Another way this is often formulated is, what is the contribution of the paper? What is new here? What's the new element? That is the concept. And that will be extracted, that will be stated explicitly. It should be stated explicitly. Anybody know where that will be stated in the research paper? The concept? Abstract. Nice. Name? What's your name?
Peter.
Peter. Okay, that's not your real name. It's okay. It's okay. So yeah, that will be in the abstract. It will be in the introduction too. So when you're reading the abstract, you look for the concept. When you're reading the introduction, you look for the concept. And if it's really written very well, it will be using very explicit words. This paper contributes the following, or our contribution is, or the novelty is this. Those words will be used explicitly if it's well written. They're not all well written, by the way. And then the implementation is, okay, you have the goal, you have your contribution, you have what's new, and then how is the concept realized or implemented? Another way of formulating is, how do the authors support their hypothesis or the answer to their question? How do they implement the concept? That's another essential element from the research paper. Two more essential elements that we're going to extract from each research paper are the core related work. So most research papers, 90 to 99%, have a related work section. And then the question is, out of all those previously related papers, what are the most important ones? There's usually one or two that are the most important. And then the question is, what are those? What are the two most important? Like parents, you could call them parents, academic parents, previous publications. and the input data characteristics. So usually, 99% of the time, a research paper, an implementation has input data. And then the question is, what are the characteristics of that input data? This is especially true in artificial intelligence, right? In machine learning, you have training data and testing data. But it's very true in other fields too, like human-computer interaction, data visualization. Usually we're dealing with data of some sort. There are exceptions, but they're rare. They're rare. The only exception I can think of is a mathematical proof. Mathematical proof might not have input data the way we're using it here, but everything else will have some input data. And we'll be wondering what are the characteristics of the data analyzed and visualized in the paper. Is it spatial data? Is it 2 dimensions? Is it geospatial? Is it 3 dimensions? Is it temporal? Is it time dependent or static? What is the size of the data? Is it structured or unstructured? Is it abstract or scalar? Is it multivariate data? So we make notes of the input data. What is the input data that we're processing as part of the implementation? Sound like fun? It's really fun. For me, you might think, oh no, like I'm going to die, right? You might be thinking that. Nobody's really thinking that, right? If you're concerned about this, think of the alternative, which is you have no strategy when you're looking at research papers. You don't know what to look for. You don't know what's important. You just have it in front of you, and you just read it from start to finish. That is much worse than this. Much, much worse. This is going to actually this is going to improve the quality of your life dramatically, especially of your intellectual life. So we're going to use a template. We're using a template for coursework 1. We're going to use a template for this class. And this is what it looks like. The essential information extraction template. And it looks like this. There's a paper title with the authors and the DOI. Does everybody know what a DOI is?
It's actually got a number.
The Digital Object Identifier. That's what it stands for. And it's sort of if you have a research paper, there may be multiple versions of it online. You might Google the title and you might find multiple versions. But there should be an authoritative version, like the final version, and that's the one with the DOI. The DOI is the link to, or the identifier of the final authoritative version of the paper. So that's what the DOI is. So you want to have that. So in your template, you have a concept, which is usually 1 to 2 sentences. You have an implementation or method that's also usually maybe 2 or 3 sentences. You have a core related work, that's 1 or 2 sentences. You have an input data characteristics. Right? It doesn't even have to be sentences, that one. We also have evaluation techniques, which we're going to talk about. And maybe we can put in some other information. For example, a sample image from the paper. Maybe the paper has an interesting image. Usually papers have at least one very interesting image. You might want to put that in your summary. And maybe the URL of the PDF, for example, in your template. But that's the idea. So I love templates, by the way. I love templates. You'll notice that as you work through this course. Templates are just nice because they're very organized. They're very systematic. they're very reproducible, and they're very uniform. So you're encouraging a process, a systematic, uniform process that can be repeated over and over again. And it's very good when you're trying to manage large classes too. Very important for managing large numbers of people. So here's an example. This example is not going to be that exciting for you because you haven't tried to read the research paper yet. You're only seeing the results of this extraction process. But you can go and look at this paper and then like look at it and then say, okay, I can see the solution here. How did Bob get to that solution? How did he pick out the concept? Where can I find the concept? Where can I find the implementation? Where can I find the correlated work and the input data characteristics? But this is what it looks like. Right, so the title is Fast and Resolution Independent Line Integral Convolution. The concept, the paper contributes a faster version of a previously published algorithm called line integral convolution. It brings the original line integral convolution algorithm towards interactive frame rates. So that's the concept. That is the concept of the paper. They've taken a previous algorithm and they've made it faster. Remember what we said last week? Most of computer science is just trying to make things faster. That's usually what we're doing. Not always, but if you can take an existing process and make it faster, that's a great contribution. Because like we said last week, most of our time is just spent waiting. If I hit Microsoft Teams, that button down there, we're just going to sit around and wait for 5 minutes. Watch 5 minutes of our life go by. And then when I exit, it's the same thing. I don't know about you guys, but every time I exit Teams, I get an error message. Every time. If I hit File Quit, it says, sorry, Microsoft Teams has quit unexpectedly. Like, would you like to restart the program? I get that every single time. Anyways, most of our time is spent waiting. So anytime we can speed up a process, it is a contribution. Now, the tricky part is the implementation. This is the tricky part of this exercise. Everything else is easy. Well, pretty easy. The implementation. So 80% of the research papers are about implementation. How did they do it? This is where you can get very, very lost in the details. And you can feel very unhappy about getting lost in the implementation details. But the good news is you don't need to know about all the implementation details of a research paper. That is not important. That for this exercise, that's not an essential. Knowing all the details of the implementation is not essential. The concept is essential. A summary of the implementation is essential, but all the details of the implementation are not essential. And this is very, very, very good news. Because in my friend's stack of research papers that was this high, 80% of the pages were about implementation. Right, so we take that stack of 1,000 pages, we remove 800 pages, and suddenly we're with a much more manageable set of information. So we need to figure out a summary of the implementation, right? Because the implementation is usually 5 pages long or something like that. It's very long, it's very detailed, it's very specific, it's very meticulous. Anybody know where we might find a short summary of an implementation or a method?
In the abstract.
It could be possible to find it in the abstract. It could be possible. It's not the place that I would recommend as the go-to for that information, but it could be possible. Any other guesses?
The end of the introduction section.
It could be at the end of the introduction section. It could be. It might not be, but it could be. Any other guesses? There is a section called implementation or method in each paper. It might not use those exact words. Sometimes they do use those exact words like method or implementation. But there is a section dedicated to the implementation of every research paper. And that section has an introduction. It has all good research papers will have an overview of the implementation before they get into the details. So you have to look for that section on implementation and look at the first paragraph. And then there you will get a summary, a concise summary of the implementation. Now this is a skill, right? This search process, you're searching and you're looking, oh, there it is, like, I spotted it. It's like bird watching. And then for this particular example, there is exactly one paper that is the most essential previously related paper. They are taking a specific algorithm and making it faster. So the related work section is big. It's a big section, maybe a page, with lots and lots of references, maybe 20 to 30 references. But there's one that is the most important. And it says like, this work builds upon this previous paper. There's an explicit statement there. That's going to be in the related work section. Sometimes this is a little bit tricky. Sometimes it's not so obvious what the core or related essential work is. And then the input data characteristics, for this particular case, it's quite easy. The input data is two-dimensional, right? It resides in a plane. It's steady or static. In other words, it does not change over time. The resolution is uniform. It's on a structured regular grid, and it's vector field data. So the input data characteristics in this case are quite easy, quite straightforward. There's no guessing going on there. And there's a sample image from the paper. So it helps to remember, like, what is this paper about? And now, just by looking at the image, I can remember, like, oh, I remember this paper as the faster version of a previous paper. Any questions about that? Like I said, you'd have to go back and read the paper to see where I extracted all this information from. There are other characteristics we could include in the template. The ones we looked at are the essential ones. We will also look at analysis and evaluation. So how did the authors actually evaluate their concept, right? What basic analysis techniques are used? Is it statistics? Is it a visual analysis? Is it software? How is the research being evaluated? For example, are the researchers measuring performance time, like in the previous example? That's the evaluation technique, measuring performance time. It could be a human-computer interaction experiment, like getting people to look and interact with the software, and then recording their accuracy and response times. That could be part, or it could be a case study. That's when you take an existing algorithm and you apply it to a specific case or application scenario. Here's a little bit more about the different kinds of evaluation techniques. Most evaluation techniques fall into one of these categories. And we've already mentioned them basically. Performance-based evaluation, software performance-based evaluation. Does the implementation focus on software? Is the new software faster? Is it more accurate? Or is it more memory efficient? Usually, it's one of these three things. With computer graphics and visualization, fast speed is really a common goal. With AI, accuracy is one of the most common metrics for evaluation. Right? Memory efficient is old school. That used to be important. Now everybody just doesn't care about the memory. A good example of memory inefficient is ChatGPT. Right? ChatGPT is not memory efficient. It's using, anybody know how much memory it uses? It's using like, I don't know, $10 billion worth of hardware or something like that. A lot, more than any one of us can afford. So it's not memory efficient. Human-centered evaluation. This is another style of evaluation that's very, very common. Is there a user study conducted? For example, do they develop a piece of software and then they test it with people to make sure that people can use the software? Are there a set of general users given, and are they given a set of tasks to complete? That's called an empirical user study. It could also be a set of expert users, so users that are very specialized in a given area. That's not the same as general users, right? And it could be application-centered or a case study evaluation. In other words, is the software shown to solve a very specific problem, case, or a specific application? You know, that's another type of evaluation. Like, we have developed this visualization software specifically to operate for security purposes. And now we're going to demonstrate how we've spotted a cyber attack, how we visualize a cyber attack using this software. That's a case study application. It's not necessarily faster. It's not necessarily like a user study. It's just showing how we can solve a very specific problem in a specific case in a specific application. Questions about that?
Yes. So when it's written software demonstration, so does that also mean, like, in terms of, let's say, typing your dissertation or your academic report, when we have to give a software demonstration, will it be like a link to a functional web page that demonstrates the research that we wrote, or is it going to be?
That's going to depend on your project, how that demonstration is going to play out.
Okay.
The most common way, though, is you create a video that demonstrates the software. You create a video of video demo.
Okay. Thank you.
Any other questions about this? Here's another example.
Sorry,
Did somebody have a question? Yes?
you spoke earlier about contributions in computer science making things faster.
Yes.
There have been an instance where it's been the other way around, where slowing something down has been beneficial based on something.
Yes, definitely. So he asked, is it possible to slow things down and still make a contribution? The answer is yes. If you turn into an expert in this, if you turn into a computer science expert and you become really an expert at this, you will often notice there's a trade-off between speed, accuracy, and memory efficiency. So somebody might make something more accurate, but the cost is slowing it down. Like, the slower that thing is, the more accurate it can be. So it depends on your goals. If you want the highest accuracy, typically you require more time. And you'll notice a lot of computer scientists cheat. I would call it cheating, personally. A lot of people would not call it cheating. But if I just use an unlimited amount of memory, I can cheat and I can make a process much faster and more accurate by occupying a large amount of memory. ChatGPT is a good example of this. It's very fast and it's kind of accurate, but it occupies at the cost of a lot of memory and a lot of CPU power, right? A lot. So it's very, very bloated. It's an extreme example, you could say, of this scenario. So in all of the research, if you want to be really advanced and really clever, you can look for the trade-off. As soon as they say, we've got a faster version of this algorithm, you could look for the trade-off. Oh, I bet they are using more memory. Or I bet their accuracy has been reduced, and vice versa, for all those different traits. If they say, we've got the most accurate algorithm ever, you can automatically assume to yourself, oh, I bet it's slower. Oh, I bet it uses a lot of memory. And you can sort of debug. You can find out how are they cheating. It's very common. Okay, here's another example. We won't go over it in detail because we're out of time. And here's yet another example, and we won't go over it in detail. But you can go over these as an exercise at home. Yeah. And then we had a little bit of comments about breadth versus depth. Any other comments about this topic? Does everybody think they can do this? We're going to keep talking about this. This is not the last time we're going to be talking about this. We're going to keep talking about this. Any questions? Okay, I think we're out of time, so we're going to stop now.